Welcome back. Now, in this episode, we'll wind up the remaining part that is there, very small part which is remained to explain on arithmetic progression theorem. And here we are going to establish uh, any term, let be rth term from the starting end any term, let be the rth term from the starting end. If I know that rth term, then what would be the term from end? Okay, now I'm saying that the starting end means there are always two extremes. So I'm referring the starting end means from the start point, and end is where it is finishes. So that's this end is finish point. Okay, finish point. So if I graphically represent it with a line that there are so many terms in it, and any term starting from here having said as rth term, what would be the position of the term from the end term? So if I name it as the first term, and that is by A, and this is the last term which is given by L, say the last stands for L, then what is the term number from the end? Now basically, if we see any number of any set of numbers, so for example, if I see it like that there are, let's say I'm taking 7 terms. Okay, I'm just moving with a small example so that it can be easily acceptable and understood. So let's say I am talking about the fifth term from here. Okay, this is the fifth term from here. Now from the first term, it is in a fifth position, that's why it is fifth term. Now what about it is from the last term? If we count it, I will get 1, 2 and 3, because I'm counting from the first position from the last end or the finished end. So if you count it, I will get 1, 2, 3. So that means if I count it from here 1, 2, 3, 4, 5, and if I count it from here, it is 3. So if I add up the count, I will get one more than the number exists here in the set. Let me take another example where I will count different different count of number. Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's say I'm just taking few more numbers so that we can establish some rule out of it. Now here I want to get the seventh term from the first position. 1, 2, 3, 4, 5, 6 and 7. So I mark it as 7th. Now we'll try to count from the end. What I will count? 1, 2, 3, 4, 5. So from the end I am getting fifth. So if I add this count, how much I am getting? 12. How much here it is? 11. So every time you can see whatever the count I am getting from the either side, if I add it, I will get one more than the count actually exists. So we can put a rule that we can, if it is understood by you, that from wherever I am counting, if I add the count from either end, I will get one more than the number exists in the actual set of in the actual set. That is, the set of numbers is one less than the count I am getting together from the either end. So that means if I say the any number from starting, any number means any number from the starting plus the, or I will rightly said, it is any count from starting plus count of the same number from back or end of a set of numbers is equal to the actual count of numbers minus 1. Can I say that? Isn't it? So that means if I have to know the count of the number from the last end, we can easily say that this is count of the number from the back end. If I want to get it, so how will I get it? The actual, so I can formalize it, the count from end means back end can be written as actual count of numbers, okay, actual count of numbers minus count of the number from front minus 1. So that means if I have 7 as a count, actual count, so if the number I am getting from the start is 5th, so my count from the back end will be 7 minus 5 and count of number, sorry, this will be plus, sorry, what I am getting, the count of number from the start point, the count of number from the back is equal to actual count plus 1 I am getting now. 5 plus 3 is equal to 7 plus 1, then it will be equalized, so I am getting 1. So what I have to say, if it is the 7 is the total actual count of the number, then I will minus the count from the front end and then I will add 1 to get the count from the back end. So that is the formula I have established right now by the practical example. So in any AP series, if I say there are in an arithmetic progression, if there are n digits or n numbers, you can say, particularly you can say n numbers, and the rth term from the starting point, would be equal to n minus r plus 1 from the finish point. So this is the rule that I have established. Any count from the front is equal to the n minus r plus 1 count from the back end. So if I say in an AP series, let's say, which is being represented by a plus d, a plus 2d, dot 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 dot, and the last term is l, then if I say that t rth term of the series can be represented at tr is equal to a plus n minus 1 into r minus 1 into d. This will be the case. And what would be the term if I say the term that as I said, this would be the n minus r plus 1 from the end. So then t n minus r plus 1 will represent the same number from the back end. But what would be the n minus r plus 1th term from the back end? If I consider the term from the back end, the changes that will happen is my first term would be L, and the previous term will be L minus D, because here D is increasing in every progressive term. So unless it is L minus D, the next term would not be a L. So my from the last end, if I consider that this will be the same term considering this, okay, this is the rth term from the first end, and the same if I see as per the rule I have derived that it will be n minus r plus 1. Now let's see n minus r plus 1 from the back end. It will be the first term will be L plus my numbered term is n minus r plus 1th as per this formula minus 1. This will represent the position of the term. That means in this case it is n minus r plus 1, and as per the rule I have to deduct minus 1, and d in this case it will go reverse. That means if I go from the back to fourth, so then your d will be minus, because in this case the consecutive term will come this term later to this. So as per the common difference rule, the consecutive term will be treated, the later the term will be treated as the progressive term. So if I start from here, my next term will be this. So in that case my common difference will be L minus D minus L. So this case it will be minus D. So I have to multiply it with minus D in the formula. My formula is this, but accordingly I have to put the term as it is from the first end or the starting point. It will be considered as this is first term, this is the position of the term, minus 1 into the common difference that I will get from the deducting the next term, the previous term from the next term. And in this case, this, if I consider I am starting from the last end, so this will be the first term, and the common terms will be the next term minus the first term. So this way it will come minus. Now see, L plus this will come, this minus will be coming here, and it is be minus 1 plus 1 will be cancelled, n minus r into d. Now whether these two things are same or not, so in this way if I see this is the last term, that means the, if I say this has n number of terms, so L will be the nth term if I see it from the first end. So L is nothing but a plus n minus 1 into d. considering from the first and nth term is this is last term. So if I replace the value of L, this is n minus 1 into D minus n minus R into D. So this is equal to if I if I simplify, D will get common n minus 1 minus n, because the bracket will be removed and minus will be adjusted inside with its sign. So minus and plus here will give you minus, minus and minus will give you plus into D. So here n will be cancelled out. Ultimately what I will get is R minus 1 into D. Now see the Tn minus R, this was the n minus R plus 1 when I count it from the back end, and this is I am counting from the front end, and this must be same term. This will represent the same term. Now seeing the value, you can see the both are representing the same term. So any term from the front end TR will be the same if I count it from the back end, and the relation will be the any term Rth will be the n minus R plus 1th term from the back end. So this is the one concept. If it is to be calculated, either you can put the value directly as per this, where the term, the count of the term will be n minus R plus 1, or else what you can do, when this is the series being given, which is declared as a AP series, what you do to find the term from the back end, you can reverse the term and you can write the series from the reversing, and write the series from taking the last term as a first term, and progressively you can write the terms. From there also you can find the term directly. That also used here, this concept I have been used here, so that you can reverse it and can find the term from the back end. Okay, so now if I see in any particular term, let's say I am having one series 1 3 5, then odd series I am taking dot dot dot, and this is extended up to 21. Now in this, if I say that find 8th term, find 8th term, find 8th term from beginning, find exact number from end of 8th term from the beginning. So if I say what is the term number, if I consider the 8th term from the beginning, so 8th term from the beginning, if it is R is equal to 8 here, so from the last, what would be the number? It will be, because here you can see the total number of terms you don't know. So first thing what you have to do, we have to find the number of terms. So how will you do that? Now Tn, if I consider the last term as the nth term, so that is equal to a plus n minus 1 into D. Now what you can see, you can find the Tn value, that is 21 here. Okay, 21 here, and a is your 1 plus n you don't know, then you have to find it out, n minus 1 into D is equal to 2. So from here you can easily find n by calculating the numbers, this equation, and you can find it n is equal to 11. Now once you have find the n is equal to 11, so the 8th term from the front will be the n minus R plus 1 as per the rule, and which is equal to 1 minus r is equal to 8 plus 1, that is equal to 3 plus 1 4, fourth term from the end. Understand? So that also can be calculated. See, 8 plus 4 as per the rule is coming 12, and it must be 1 higher than the number of terms, and now n is equal to 11. So that also can be cross checked by this, the way I have established the formula for the finding the term. Okay, so now we'll move on to some examples. This is the end of the theory that is there on arithmetic progression, because there are one more subject related to arithmetic progression, but that needs some time, that is harmonic progression. But prior to that, there are one more series, geometric progression, that will cover one after one. Once I have done this theorem, I will do some sums on arithmetic progression, and then after move to the subject, because in harmonic progression, that is a related term to the arithmetic progression, needs some understanding. So I will take up separately on this. Okay, so now we'll move to some examples on arithmetic progression. Okay.